Hello there, it's Alana Tucky, and in this technology video I'm going to show you how to use your calculator to find critical z values for a confidence interval. Okay, so let me remind you here, we want to find z alpha over 2. So let's look here. If you have a 90% confidence level, and that I kind of drew a picture down here, that means the center part, because the confidence interval is symmetric, the center part is 90%. So that means you have 10%, which is your alpha. Alpha is on your tails. So here, let me put that in there. There we go, 10%, which is 0.10. Okay, so that means alpha over 2 would be 5%, right? Because you take 10%, you cut it in 2, which makes 5%, which is 0.05, right? So that's how much is in each individual tail. That's why we have to cut it in half, because the confidence intervals in the center, you have 2 tails. All right, then the critical value, that's what we're trying to remember how to find. And we learned how to do this in Chapter 7, but this is just a little reminder. You need inverse norm, 0.05, comma 0, comma 1. All right, let me show you how to do that. So you grab your calculator, go to distributions, so second variables button right there, and then number 3, right there, inverse norm. So you grab that, you say I want 0.0501, paste. And for old calculators like 83s, that's what it's going to have to look like. Inverse norm 0.0501, press enter, and there it is. So it found the one on the left. So the one on the left is negative 1.645. So this one over here on the left is negative 1.645. So the positive one, which is actually what we were really looking for, is over on the right-hand side. So z make this over fraction. There we go. Is equal to positive 1.645. So by doing 0.05, I found actually the one on the left. But I really wanted the one on the right. I wanted the positive one. Now, the other way you could have done this is if you would have done 95 instead of 05. So if you did 95 instead of 05, you would have gotten it. Here, I'll show it to you. So if I go second distribution, number 3, and I say 0.95, enter, enter, enter. There we go. Paste, enter. There we go, positive. So what's happening is that inverse norm, remember, always wants the area on the left tail. So if you want this one over here on the right, you need all the area to the left. Well, that's 0.05 plus 0.90 together. So that makes 1.645. So there's that critical value. All right, so now let's do it again. So for 95%, oops, let me go grab you a picture. There we go. So 95% is in the middle. So that means alpha is 0.05. Oops, close. There you go. 0.05, right? The complement of 95%. So that's the 2 tails put together is 0.05. So alpha over 2 is equal to 0.05 divided by 2, which would be 0.025. All right. So then z alpha over 2, let's find that. So if you want the positive one on the right-hand side, you could either just find the one on the left and then make it positive, or you could find the one on the right. So that'd be inverse norm 0.975, comma 0, comma 1. Now I'm getting the 975 because I'm taking 0.95 plus 0.025. Or if you like, you can just do 0.025 and then just make it negative, right? Or positive, excuse me. The opposite of what you got. So you'll get, I know what you'll get, but let's prove it to you. So if we go second distribution, number 3, 0.975, down, down, down to paste, enter. And there you go, 1.96. And just to prove it to you, if you'd done 0.025, it would have been fine. It's just, it will make it so that it's the opposite. It's the negative of what you were looking for. There we go. Right? So 0.975 gets us 1.960 when you round it. All right, so there's that one. Then we have one more, which will be 99%, but I think you get the general idea. So let me pause this. Okay, so there's a picture of it. So you got 99 in the middle, so your alpha is 0.01. So then your alpha over 2 would be 0.01 divided by 2, which would be 0.005. All right, and then that means Z alpha over 2 would be, now let me copy and paste this. All right, so we want 0.99 plus 0.005 would make 0.995. All right, so let's go do that and see what we get. Let me clear this out so you can see better. All right, so distribution number 3. You can either do 0.005, that'll be the opposite of what you're actually looking for. That'll be the negative one. Or you can do 0.995. Enter. And there we go. 2.576. All right, so we get 0.995, that's 2.576. There we go. Now, if you're stuck on a test and there is another thing you can do, which is using the tables. So there's a couple tables you could use. I'm actually just going to show you the quick reference from the t-distribution table. Don't worry about what the rest of this means at this point because you don't know yet, but it's coming in the next section. But I just want to show you the one we just did. We said it was 0.005 in the tail, right? And if you look at the very bottom of the t-distribution table, you can see it says Z. That's because the very, very, very bottom of the t-distribution table is z-scores. We'll worry about what the t-distribution table is in another one. Now, this is just a quick reference for some of the big ones. So the one we just found was 0.005. So if you go to the very, very bottom of that column, there it is, 2.576. Another one we found was, let's see, 95%. That had 0.025. See that? So then if I go to the table, which you're given on your final exam and your test, you go to the 0.025, go to the very, very, very bottom for the Z, and you can see it's 1.96. So this is a quick reference for some of the big ones that we use the most often. If you're given another one on an exam or something, you'd have to find it either with this table here or with a calculator or something like that. But I probably wouldn't give you something like that on a final exam. So I would be giving you ones that either have quick reference or something like that. But for those of you that are in the face-to-face class, exam 3, I expect you to all know how to do inverse norm to find anything you like. And let's see, just in case you're interested, if you want to know how to use this table to do it, just for sake of argument. All right, so remember how we said the area in that last one we did was 0.005, right? Okay, so what you do is you go through the table and you look for where is the closest to 0.005. You can see, okay, here's 0.0051, here's 0.0049. So it's between negative 2.57, see there, and negative 2.58. See it there? So negative 2.58. So it's negative 2.57 and negative 2.58, somewhere in there. That's how you do it. So it's kind of strange because it's not really very exact. Oh, there's another one down here that has some other quick reference that you can use. See, they're using negative 2.575. We just saw it with the calculator. It's actually negative 2.576, but it's close enough, right? Right around there. Let's see, what was another one we found? We found by hand or with the calculator. This one, 0.025. We said it was 1.96. So let's see. If I go 0.025, 0.025, I'm looking for an area that's near 0.02. Okay, it's 0.0217, 0.0212. I'm getting closer. 0.025, where are you? Oh, there it is, right here. 0.025, look at that. So it's negative 1.96, because that's the column it's in. So negative 1.96. Perfect. That's how to use this table to find those values if you need to. But again, a lot of the ones you'll be given on a test, matter of fact, all of the ones on the final will be something from this quick reference chart right here. All right, I'll see you back here for more technology videos. Next time, I'll show you how to do a confidence interval with your calculator.